Welcome to the Explainer. This is where we take big, complicated topics and just break them down. We'll get you up to speed and we'll do it fast. All right, so are you feeling ready for your trials? I'm guessing if you're in year 12 for software engineering, they're pretty much all you're thinking about right now. So let's spend the next 5 minutes connecting the dots on some of those key syllabus topics. Make your revision a little more effective. Okay, so here's our plan. We'll start with handling data, then communicating securely, designing for trust, building with AI, and finally, go live, testing, and reporting. Basically, we're going to follow the life of a modern application from the ground up. All right, first up, handling data. So how does your application actually talk to its database? Let's dive right in, because this is the absolute foundation of, well, everything. So you've got to know your raw SQL. It is the language of databases. I mean, look at this query here. You're directly asking the database for exactly what you want, no messing around. You're selecting usernames and ratings from customers with a rating of 70, ordering it just so. The key takeaway here, it's all about control. You get to be super specific, no middleman, just a direct line to your data. Now, writing raw SQL all day, it's powerful, but it's not always how we do things anymore. Enter the ORM, the Object Relational Mapper. The best way to think about this is like a universal translator. It creates a bridge, right? So your Python or Java code can work with data as if it were just another object without you having to write a single line of SQL. It's way faster for development, and, this is huge, it can help you avoid some really nasty security errors. Okay, section 2, communicating securely. So, we've got our data out of the database. Awesome. But now, we need to send it across the web. How do we do that without it getting snatched? This is where protocols come in, and for your exam, you really need to know the difference. So you've got HTTP, that's the basic language for websites. Then there's TCP/IP, which is kind of like the internet's postal service. It breaks your data into little packets and makes sure they all arrive safely. And then you have SFTP. Think of that one as the armored truck for your files, super secure transfer. And that little padlock you see in your browser, that's all thanks to the SSL handshake. It's actually a pretty cool little dance. Your browser, the client, basically says, hello. The server says hello back and shows some ID, its certificate. Your browser checks that ID to make sure the server is who it says it is. And once they've authenticated, they create a secret key to encrypt everything else they say to each other. It's this digital handshake that makes secure communication possible. All right, on to section 3, designing for trust. You see, a system can be technically secure, but that's only half the battle. Earning a user's trust, that starts way earlier, right at the design stage. And this is a super important distinction for your trials. Security versus privacy by design. They sound similar, but they're not. Think of it like this. Security by design is all about protecting the system itself from threats. Building the castle walls high to keep invaders out. But privacy by design, that's about protecting the user's data inside the system. It's about making sure their information is handled with respect from the get-go. And that leads to this crucial point. You can absolutely have a secure system that doesn't respect user privacy. I mean, a system can be a digital Fort Knox, completely unhackable, but still be doing shady things with the user data it holds. These two concepts are not the same, and that's a key thing to grasp. Okay, let's get into the really cool stuff. Section 4, building with AI. Now, when you're implementing machine learning professionally, it's not just about writing some code and praying it works. No way. There's a proper process called MLOps. And that whole life cycle starts right here with stage 1, the design stage. This is where all the planning happens. You start with a business problem, right? Like, we need to predict our sales. Then you have to reframe that as an ML problem. In this case, probably a regression task. And this is so important. You have to define what success even looks like. Are we happy with a 5% error margin? You have to figure this out before you do anything else. Okay, plans in place. Next up is stage 2, model development. This is where we get our hands on the data. First things first, data wrangling. And yeah, that's just a fancy term for cleaning up messy, real-world data. Once it's clean, you can train your model. You might use something simple like a linear regression for a straight line trend, or maybe a polynomial regression if the pattern's a bit more complex. And then, of course, you test and validate it to make sure it's actually working. And finally, we get to stage 3, the operations stage. This is it. The model goes live in the real world. But deploying the model isn't the end of the story, not even close. You have to constantly monitor its performance, looking out for something called model drift. See, the world changes, right? Customer habits change, so a model that was super accurate last year might be totally useless today. That's drift. And when you spot it, it's time to go back and retrain the model with new data. So our app is built, our AI is humming along, we're at the final stage. Section 5, Go Live, Testing and Reporting. It's time to launch this thing, but we have to do it right. When it's time to go live, you've basically got 4 main strategies, and you need to know the trade-offs for each one. You could do a direct cutover, just flip the switch. It's fast, but super risky. Or you could do a parallel adoption, run the old and new systems at the same time. Really low risk, but really expensive. Then you've got phased or pilot adoptions, which are more gradual. The point is, there's always a balance between risk, cost, and speed. Okay, the system is live, but you can't just cross your fingers and say, yep, it's secure. You have to prove it. And that's where the security report comes in. And this whole process is something you'll want to have down pat. You start by just gathering information about the system. Then you run automated vulnerability scans. That's like the first line of defense. But then it gets serious. You do manual penetration testing, where an expert literally tries to break in, testing for all the big ones, like cross-site scripting and SQL injection, and then everything they find, good and bad, gets documented in a formal report with recommendations. That report is your proof that you've done your due diligence. And there you have it. We've gone all the way from a single line of SQL to a fully deployed, AI-powered system. We've seen how data, security, design, and deployment all fit together. So now, the real question is, which of these areas are you going to master first? Go get them and good luck with your trials.